Well, welcome to the July 8th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I have been reorganizing the shack and reorganizing some of my computer OS systems while maintaining all of my receivers that are uploading to Whisper Demon. So it's like a juggling game. But I'm trying to try a few different configurations, try to clean up my antenna feed system a little bit. So that's about it for me. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Steve. As we were saying before the recording started, Elmer Muster, N3AGE, is visiting me here in Scranton this week, and he's doing a lot of work to try to do some antenna work and RFI mitigation for the ARC 888 personal space weather station, and also see if we can resolve some electromagnetic compatibility issues between the VLF system and the HF system. So we had day one of that today, and he made some repairs to the SAS antenna system. He installed the last time he was here, and he set up his own independent VLF receiver with the power supply that he showed last week. So that's set up now in my yard, and we're going to do some tests and experiments with that tomorrow. I'm hoping I'm going to focus this week on getting the spectrum right, because I know that my systems are not reporting to the reporting data to the Alabama server. So we need to do some software work on that. I'm going to focus on just working with Elmer on the hardware stuff first and on the spectrum, because I can do the software stuff myself, but I don't have the skills Elmer has for doing this other work. So I'm very grateful that he's here. And I had a bunch of students come up to the house today too. The other cool thing is if QST has made it into your mailbox yet, or if you go on the digital edition, you can see that there's now a special section, the latest from HamSCI.
Oh.
And yeah,
Yay!
so we made the front cover, and there's Yeoman and some of his students, and there's my student Rebecca and Nina, and some of us are standing in the background, and they gave us a 14-page special section.
Wow.
Which I know, which is just absolutely, amazing. So if you look over here, special section, HamSCI, the Ham Radio Sciences Investigation. And so,
can't wait to see it.
Yeah, so here's our photo from Dayton this year, which was really nice. And I wrote the first article, and then my friend Ethan Miller, K8GU, and I teamed up together to write the second article about traveling ionospheric disturbances. And then the ARRL picked their favorite presentations from the HamSCI workshop and contacted each of those presenters and had them write a 500 or so word summary of their presentation. And
wow.
Yeah, and then that's how they built out the entire special section. So I think it's really neat that you can go see this, and they link right to the HamSCI website now. So I mean, it's a pretty big deal now.
Great.
This is great.
I know it's both exciting and a little scary that it's kind of this big, but I think it is very nice that they did that.
It's well-deserved attention.
Well, thank you. And
so you're lucky they didn't just stick you in QEX because it was too technical.
I know, and a lot of things do end up in QEX, but no, this is front page of QST and a very large portion of the magazine, so that's kind of cool.
So, well, congratulations.
Thank you.
To your credit, Nathaniel, you're doing something very different than any other people in the ham radio have been doing. So you should be congratulated for that.
Well, thank you. And thank you for all of your help because I couldn't do it without you. So.
But it says, but at the same time, addressing some of the perennially um, expressed goals of ham radio these days about getting younger people involved and
Yeah.
doing new things, and actually some standard things, including, why RF transmission happens the way it does, and so on and so forth. So
Yeah.
yes, congrats.
Thank you. And yeah, I'm happy to say we've probably licensed about 4 or 5 new students this summer, just within the past
Okay.
few weeks. So it's been good. And my student Owen, he's very excited. He just told me that he came over to my house and he's like, I just bought a Yaesu FT991A. And he's like, I didn't tell my parents until after I bought it. And I'm like, He's like, now I'm gonna upgrade to general, but he was very excited.
He's learning to be a ham.
Learning the fundamental skills.
So anyway, back to net.
Okay, so next on the list, we have Dave, KD0 EAG. Go ahead, Dave.
Well, I've been, I don't remember exactly, I've been doing, early on, I was doing schematic work, but I have had a whole lot of network adventures, and with my ISP and so forth, who finally came out and admitted that, yes, there wasn't hard, it was just a few kilohertz coming across that 1 gigabit line. But and rerouting thing, trying to reroute things around the house, and on and on and on and on, the usual stuff. And then some new equipment. So I've been a little bit distracted, but I'm also doing some fundamentally basic things. So that's my that's my that's my 2 cents worth.
Okay. Next on the list, we have David New, N8 SBE.
Yes, hi.
Yes.
I'm usually just the fly on the wall, and I love listening to these things, and of course I'm all the time curious about anything new and unusual. So what I've been deep diving in on ever since Dayton is the Meshtastic.
Yes.
And I just got my Seed Studio solar roof node a couple of days ago, and I've got that all set up ready to go. It's sitting on the table in the patio right now, but tomorrow maybe sometime I'll climb up the tower and put it up on the tower. And but that's really the thing that I've been mostly diddling with here on this end. But I know that really doesn't
It
have
is-
much to do with what you guys are doing. But
Well, it is a neat system, and at least a couple of us I know have gotten involved in it in our local communities as well. So
yeah, well, I mean, I've turned once I turned on MQTT on here, I started picking up stuff as far away as Chicago and in the Upper Peninsula and elsewhere. So that's been a lot of fun too. So
very good.
all right.
So next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Not a whole lot with ham radio going on here. I need to start doing some serious VLF work now. I've got the rudimentary parts of a receiving setup done, and see where I go from there. But I just haven't gotten around to it yet. I need to get that round to it out and get it polished up. Back to
Okay.
net.
And next on the list is Bill Engelkey. Go ahead, Bill.
Okay, thanks, Dave. It's been busy here. I got back the repaired inner tower section from my tower that had been destroyed, and they welded it back together. And it works for the most part. It's shorter and it doesn't slide properly for the last few feet, but it's serviceable. So as $250 for the welding as opposed to $3,800 to get a new one from Illumitower. So I thought I could tolerate some reduced functionality. As far as project work, been doing a lot of processing of the Grape One data from the WWV club server, trying to get that off the club server and onto the PSWS system. Have been unloading disks and saving to box. I'm down to just 1 or 2 left that we'll have in box. They still have to be processed. In other words, they have to be converted to DRF and plotted and put on the system, but getting them safely saved. And of all the 30 or so disks I got, there's only one that failed to mount. And but we had the backup data from the USB drives, the little thumb drives, for the time of right immediately before and during after the eclipse. So that's good. Helping people with their conversion of their Grape One legacy systems to upload personal space weather system network. We've converted, I don't know, 8 or 10 of them so far, with another couple of dozen to go, but that's an ongoing project. The new personal space weather station network server just came online and became available to me just this afternoon. So we have a lot to do to get that prepared, because it's like basically an empty box that has to have everything installed on it. So that's going to take a little while, but we're getting there. Oh, and finally, I've made some progress on the design of the interface to allow science users to control channel access on receivers, primarily the RX 888 and ones compatible with those. So that's coming along, but other things are also competing for time. So anyway, that's the story from here. Back to Ned.
Very good. Next on the list is Clint. K7OEI. Go ahead, Clint.
Evening. Let's see, my camera will eventually, there it is.
There it is.
Yeah. Well, I got a box of errant 888s from via Rob. I'm working on Michael Howland's, and the worst thing possible is happening is it is working fine. So I don't know what's wrong with it yet. I was just blowing. I got it up to boiling point, literally 100°C, and it's still behaving perfectly. So I'll probably have to set it aside and maybe run it overnight for a while to see if I can make something fail. But I don't know how many are in the box yet. Probably 4 of them, but we'll go through them and see which ones are salvageable. One of Nathaniel's is in here. I know that. The one I pulled out of the box first was Michael's.
So Clint, the problem I was observing with it was it would have a spectrum that appeared normal,
Mm-hmm.
and then unaccountably and for no reason I could figure out, the spectrum would change in a way that suggested there were these big, powerful signals kind of spread across the spectrum. And then it would go away and look normal again. Then it would come back. And then it would go away and come back intermittently. And when it was abnormal, nothing decoded.
Okay.
I could not explain. I had no indication of anything that was changing that might explain those transitions. It was not the cross the board full spectrum noise that you see when there's missed packets, or when you're sampling too fast, or there's some of those cycle issues and
Right.
timing issues that we'd observed in other cases. So that's
Right.
what I observed was abnormal about it.
Right. I'm running it on the internal clock at the moment. I haven't fired up the Bodnar yet, but it's working perfectly on the internal clock.
Okay.
And
That's good news.
Yeah, that's my first go-to is check it on internal, because it's less of a hassle. And if it works fine there, then we'll move on. But I'll try to let it run overnight. I don't have a lot of USB 3 capable machines kicking around. So we'll see how it goes. All right, that's it. Back to you.
I appreciate your working on it.
Very good. Next on the list is, well, let's go and talk to Michael.
Oh, hello.
Hello.
I've not been doing too much in the radio and HamSCI world, with one exception. I have been and made a little bit of progress in installing Proxmox. I received a new B-Link today, 5825, I think that's the right number, which is the one I think we're standardizing on for the DAISY 2 grant. My intention is to use two of them that I have here to test, on the one hand Proxmox and on the other hand Incus, and see which one may work best for our purposes in simplifying dependencies when we build an install image for the DAISY 2 grant, and in enhancing security. So that's what I've been working on. I've run down a really, really deep rabbit hole working on AI, and learning a little bit how to try and preserve a intelligent and not entirely dysfunctional context across a sequence of interactions with AI that turns out to be a big problem. You can ask one-off questions and AI will sometimes do great, but if you try to have an ongoing conversation where it's absorbing and having to integrate new information as you go along, it exhibits a cerebrovascular accident type loss of memory and agnosia and so on. I'm discovering a variety of ways to mitigate that. Among them is just stopping, changing to a new stream and reinitializing it with a code base and some reference material. That seems to help for a while, but it doesn't eliminate the problem. Anyway, it's one of these learning curve things in working with AI that's kind of fascinating, but also somewhat frustrating. Back to Nat.
Okay. Next on the list is Dave H. W6OQ. Go ahead, Dave.
Okay, good evening, everyone from Los Angeles. This week, instead of doing nothing, I saw a note about the antenna work there at W2NAF and Jonathan's comments on it, and thought that maybe I could, look into that and see if I had any ideas to throw at him. So I'm working on that. Need to get schematics for the VLF system that's installed there at Nathaniel's house, as well as the new PC boards they're working on, so I can, get into details there. I'm looking at, things like ground loops. I've had a lot of experience resolving ground loops in PA systems, sound reinforcement. So I think I know something about that. And this is a little different, but yeah, I have thoughts that it may be similar. So that's where I'm at.
Sounds interesting. Thanks for your work there. Next on the list is Dave Julian, WB9YIG. Go ahead.
Oh, good evening, folks. Been busy with trying to work the 13 colonies on the satellites. And I'm pulling my hair out on trying to upgrade or converting my Break One legacy system. Not necessarily playing well with working with the Pi, but we're getting there, I think. I finally figured out how to transfer my files, so we'll see how that goes. That's about it.
Okay. Next on the list is Scott Newell in 5TNL. Go ahead, Scott.
Hey, well, this week, I sent in some pull requests. I studied Phil's PCM record changes, and I managed to demod some of Clint's Eclipse BPSK transmissions. I am interested to know if we have a schedule for sending the hardware with Diego Sanchez to Alaska next month, and that's it for me.
I also have a question. Do you know if Phil's back at home yet, or is he still traveling? Do you know, Scott?
I don't think he's home.
Okay.
One quick update regarding Diego
He
Sanchez.
paused.
He is things got a little too busy for him because he's also doing a summer internship at APL and trying to write a paper on large scale traveling atmospheric disturbances. So he opted to not do the Alaska trip. So we're not doing a rush order on that now.
Did you get that, Scott?
Sure did. That's bad news, but that's the way it goes.
Okay.
I get it. Thank you.
Next on the list is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave. Everyone in the group. Hope the audio is working. Been working on the cost-reduced 4-channel receiver, and I think I pulled about $400 worth of parts out of it. So that's that should be good. Still working on the schematic for it. No FPGA. In the new design, there's no FPGA at all. And so I started investigating the BPSK marker, came up with a circuit that injects BPSK carrier on each of the channels, and it injects it at 1 phase reversal per second on one channel, 1 phase reversal every 2 seconds on the second channel, every 4 seconds on the third channel, and every 8 seconds on the fourth channel, but with all the edges aligned. And so I think that will allow the coherence of the channels to be recorded in something like digital RF format. And also it positively identifies the channel, since the cadence of the signal will tell you exactly which channel it was that you recorded. Otherwise, it might be possible, if you missed a few bytes, to get the channels swapped around accidentally. So it's kind of a double check to make sure that doesn't happen. I've been doing a little bit of research onto direction of arrival methods for multi-element, multi-receiver antennas, which is taking me back into linear algebra from about 53 years ago, and eigenvectors and array diagonalization, all of that stuff, and found a wonderful paper from Ham in Finland. Great presentation. And surprisingly enough, lots of good tutorials on YouTube, both on linear algebra and on the high precision DOA methods. So both of them real interesting topics. Back to the group.
Very good. Sounds like a fun excursion, learning all these different parts.
Yeah.
So I think I've called on everybody. So if we've seen no other participants, we'll open for general discussion.
Very quiet tonight.
Yes. Well, Nathaniel, do you want to talk about some of the upgrades you're doing?
So what we are doing, what I have set up at my house right now is I have 3 RX 888s connected to 3 B-Link computers, and each of those RX 888s is connected to a different type of antenna. One is the Glenn Elmore's SAS. The other is the DX Engineering RSEAV-1 vertical. And the last one is the DX Engineering mag loop. And currently, and we are doing it, we're running those 3 to basically put those 3 antennas head to head. And we got those installed about a month, 2 months ago, when Rob Robinette and Elmer Mustard came to visit the first time. the RS-EAV1 active vertical and the mag loop are both located in very close proximity to the VLF receive antenna and to the ground magnetometer. So those systems right now are the ones that are seeing the interference the most. We now have the SAS antenna that's moved much closer to my house, probably about 100 to 150 feet away from the other antennas. Let's see, I probably can, if you give me a minute here, I think I can show the spectra of each of these things. Yes, there's one, there's two, and there is three. Right. And then I can share my screen. Whoops. Slide that over there. Screen one. So here is the mag loop spectrum. And you can see all of these spurs are what's coming off of the VLF right now. And then here is the active vertical spectrum. And then here is the SAS spectrum. And so just by moving the SAS, so the SAS is about 100, as I said, maybe 100, 150 feet away from the VLF system right now. Elmer was able to significantly clean up the spectrum compared to having the ones just immediately adjacent. So I'd say that's at least encouraging that we were able to get it to perform that well. Let's see. I don't know that I have all of the proper shelving and low pass filters on these systems right now. So that's something we're going to have to put in the future. But as I said, tomorrow, well, the other thing, so Elmer set up another VLF system that he built based on Jonathan's design. But he has made modifications, a different power supply, and he has brought that here and he set that up today. So tomorrow we're going to try to do some side-by-side comparisons to see if that performs adequately at VLF while also eliminating these spurs. So that's the main work we are doing at the beginning of the week.
So Nathaniel, do those spurs disappear when you unplug the VLF antenna?
Yes, which I can do right now. There you go.
Oh yeah.
Yeah, so that's unplugging the VLF antenna, and then there it's plugging it back in. Yeah.
Yeah, that's a bug worth quashing.
Yeah.
Yeah.
So, yeah, so this is one. I think if we can solve this, then I think we're going to be in a much better place. So
It looks like it's a little bit over a megahertz switching frequency, maybe 1.2 megahertz switching frequency.
So I know that Jonathan has been very concerned about modifying the circuit he has because he's very protective of the electrical isolation between his receive antenna to protect his VLF observations, and rightfully so. And we're hoping that the solution Elmer has will still preserve that isolation and performance while also hopefully getting rid of this. So we shall see. So I think that's
does that occur at the power injection point? I mean, if you disconnect the power to the preamp, do those things go away, but still some lower magnitude receive signals come in?
I'm not
to the
entirely
VLF antenna, I mean.
I'm not entirely sure. So right right now the test I just did was I just unplugged the entire VLF antenna, which removed the power and the VLF signal. And I don't have an easy way to do that right now. But Elmer's system, I think he designed it in such a way that you can switch these things in and out, make it match the circuit Jonathan has. His system's designed to let us do some debugging. So I'm very excited to see what happens with that.
Cool.
Yeah. And so I think after that, I think that's one, the main thing that I think if we get that done, that'll be like the biggest thing to get done this week. Then after that, I have, in addition to the RX 888s here, I have a Grape 1, I have a Grape 2, I have a chirp sounder receiver. I have a lot of things that are all hanging off of one 80-meter off center fed antenna, and I have it going into some like 48 port splitter and a few preamps to try to cancel out the loss that comes from doing the 48 port splitting. I'm hoping that I might be able to work with Elmer to take one of the active antennas that we have and figure out how to distribute it to all of these other instruments, because I'd really love to have it so that I have all these instruments on the wideband receive antennas, and that I could use the 80-meter OCF dipole as a regular ham radio antenna as well, and not just for the receive, because I keep having trouble with my regular ham radio antennas coming down. I had another one come down last week, and I knew it was going to happen. It just so. But if I could move the just get all of the scientific receivers on these broadband antennas, I think that would be a better place to be. And some of the other work that has been happening recently that's good is Rob Robinette and his team. They have been creating a new HamSCI WireGuard network, and so now these systems are now they fell off of that for a little while, but they're now back on, so we can remotely access these things, which is really nice.
Nathaniel, quick question. What version of the Spectrum Analyzer software are you running here?
I don't know how to answer that question.
There was one from Scott Will.
It says current version 2.72.
Okay, is that the one from Scott or from someone else?
I don't know. It's the one that if you follow the standard procedure, Rob Robinette installed all this, everything on here. So maybe Michael Howen knows the answer to that.
Yeah, there's a couple versions.
Not mine. That's the current one, or close to current, from Jim and Wayne.
From whom?
Jim and Wayne.
Oh, okay.
Yeah.
And do you know what version of KA9Q that requires? Or is it just current?
I think this is all just current. I think when Rob logged into my system earlier this week and got the remote access working again, I think he also upgraded all the software to the current version. So I think I'm just running the most current version.
Okay, cool. Thank you.
You're welcome.
There was a recent change to KA9Q radio that would correct the spectrum. So if you're on an older version of KA9Q radio, you want to be, in the last week or so.
Okay. When you say
Bill went out of town.
When you say correct the spectrum, what was wrong with it?
At some zoom levels, the bin positions were wrong. In my case,
Okay.
I've got that carrier at 13.56, and I can zoom in and out, and it would be at 13.56. But at some zoom levels, it wasn't, and it was an off by one or an accumulating floating point error inside K9Q radio when it summed the input and output bins. But that's been
Okay.
fixed in the last week or two. So if you zoom in and out and the spectral peak moves and it's not in the right spot, you've got the bug.
I'm
It looks like
zooming
you do
in at
not have it.
10 megahertz right now. So
It was most of the way out for me, like at between 8 kilohertz and 16 kilohertz per bin. You'd have to find a strong carrier and see if it shifts.
yeah, it, it doesn't seem to be shifting right now, but as I said, Rob did work in the last week. I think he made some updates to my machine. So but yeah, that's the main stuff that we're working on right now. Trying to think if there's anything else going on that's of interest to the group. I'm sure there's tons of stuff going on.
I might mention one little thing I've been fooling with, that you maybe you've been told about this, but in order to eliminate at least one Raspberry Pi from the whole overall configuration, for reading the magnetometer, I've been working with actually several different little widgets. Where did they go? They fell off on their own. Anyway, there's one that, there's just an RS-232, no, FTDI 232H is a chip that's specifically made to go USB to um to I squared C or SPI, but for I squared C for our purposes.
Mhm.
They're on a nice little board from Adafruit. They're $15 maybe. And Paulu has one, a little one. These are little things, same kind of idea, done a little differently. They basically allow you to plug in a USB 2 connector and and interrogate um, the magnetometer without the need of a Raspberry Pi as part of the configuration. So the B-Link can do it. And if you're really concerned about, processing, you could use a little Arduino. I mean, any number of things, a little, uh, um, any number of things, almost any small chip that can uh, talk, and then it can offload that so it's not interrupted by the queries. If that were to be a collision um, with the B-Link's busyness doing other things. Anyhow, you
Yeah.
can use it as a little auxiliary thing. It also, most of them usually give you a couple of GPIO pins or something you can use as well if you want, or you've got a whole bus, so You can
Mhm.
put a number of different I²C things on that chain.
Yeah.
Should you want to, if you want to measure keep an eye on hours of daylight or something, I don't know, any number of things. But that way, um, and then just plug into any of using either, uh, it needs an adapter to make it, well, this is for the client side. This is for the near side right now.
Right.
And this would just eliminate the Raspberry Pi.
Which would be very useful.
The only downside to this is that it needs some new code written because it doesn't, you don't, it's got a little library, and
Right.
essentially each of these is a little microprocessor, and they have an API, or you can use a little microprocessor, uh, like a ESP32 or something. Anyway, that gives you the option of, actually in the longer run, of building all sorts of mix and matches if you want to connect via remote, other remote strategies. But even using the stuff you've already got, this just lets you hook it up to a B-Link. And
That's really, really, really useful.
yeah, I didn't think that we've kind of mentioned it in passing, but I didn't know whether anyone if it had sunk in with anybody. But that could save a lot of trouble. And, one more power supply, one less box, one less,
Yeah.
everything.
And my understanding is there's lots of processing power available on the B-Link, and the magnetometer requires very little processing power.
Very, very little.
Very little. So
Yeah.
I think, yeah, Dave, if we could do this, I think that would be ideal.
Oh, it's almost done.
Okay.
So and Michael and I in particular have been talking about it a lot. And yeah, the idea was to get the number of things down, that can break,
Hmm.
and that cost money.
Yeah.
So it's just more options that simplify.
Yeah. I think if if you have that working, we haven't really deployed any Daisy 2 magnetometers yet.
Yeah.
I'd much rather just deploy with a single B-Link rather than a separate Raspberry Pi.
Yeah.
Yeah.
And take that money from that Raspberry Pi and buy these slightly more expensive um, Bodnars that
Yes.
have a pulse per second output.
Right.
I would feel better if somebody would validate the synchronicity of the pulse per second, but you've got, it's a newer Bodnar, and I would buy those instead of the older ones.
Which is what I'm planning on doing.
Okay, good, good, good. And so all is, I think that'll do you well in that dimension.
Yeah. So I did get a quote. John Gibbons was able to get a quote from Leo Bodnar for buying like 25 of them, and he gave us a reasonable price on them. So right now, I am planning on buying all of those, the new 2-port ones. But I think one thing we're working on right now is still like just kind of the project management and the distribution plan for all of these things. We don't, as you can see, there are still a number of little details that are not worked out, like the VLF issue. Now, I think now trying to get rid of the Raspberry Pi, which I think is good. I don't think we purchased Raspberry Pis yet. So I think this is really good information to know. We did buy all the magnetometers from TAPR already. But I'm working with another professor at the university, Bob Spalletta, who teaches engineering management, and he's trying to set the whole project up in Microsoft Project and help me with the project management. So hopefully, and I know, and Gary McKeaton's working on this, so hopefully we're gonna get our process of ordering and distribution worked out. But this is really, really useful, I think.
you might, if you haven't already done so, you might not want to put together those magnetometers yet that you got from, the solder onable parts.
Okay.
Or at least talk about it. Uh, because really, I suspect you could double your number of them you might only need the remote one. I don't know. We need to think about
Yeah.
what we're doing. There just may be an easier way.
So we might want to talk to Majid about that because he is the one that has been keeping those, and I've basically assigned him to just go work on assembling those together.
Yeah, and I haven't talked to Majid in a while, so that would be
Yeah.
nice. But anyway, this is just one of those details that might get forgot. But could, a Raspberry Pi is at least $100 per
Yeah, no, that's a big
connection.
deal.
Yeah, that can certainly be better used somewhere else.
That is definitely a big deal. Thank you very much. And the cost of certain things have increased, now that we're looking at putting the 3060 megahertz filter in, that's more expensive than the original filter we were looking at. And then the we're looking at using the new 2-port Leo Bodner. That's a little more expensive. So yeah, these BOM costs are adding up. Well, if that's it for tonight, Dave, I might say
Okay.
73. That way I have enough energy for doing all of this, working on this
Elmer?
again tomorrow. Yes. But
Well.
I think this is good
Definitely Elmer is a high
progress.
energy fellow.
Yes, yes. And I think it went well today. And I think we had 3 students up here at the house with him, and I think they enjoyed learning from him and helping to string wires and set up antennas. And Elmer even had my son feeding magnet wire in through the SAS antennas. So yeah. Oh, one other really neat thing that I did this weekend. So my family and we went up to the Finger Lakes this weekend. And
Yeah.
do you know what is at the top of the Finger Lakes? The Antique Wireless Association Museum.
Oh,
Mm.
Yes. So we went to go
Very
visit
good.
that on Saturday, and it's an absolutely beautiful, beautiful place. And they gave a fantastic tour. They kept my son interested for about 2 hours, all about old radios, and they have like a
Yeah.
nice. They had a nice display where they had a recreation of the Titanic radio room. They had one of those Jacob's ladders set up. They have a whole room of working teletype machines, including this waterfall one.
Wow.
They have a VOA, Cold War era transmission console there that was shipped from California to their museum. It's absolutely. Let me see if I have a couple photos because it really. If you have a chance to get up there, it's really, really, really worthwhile. Yeah, and they actually just here we go. Yeah, so here's the Antique Wireless Association. They just put this tower in, and they actually said they just put the Yagi up last Tuesday. So this is actually a very new installation. And yeah, so this is Tim. What's this call? I've been meaning K9VB. So K9VB gave us the tour, and this is one of the first, places he brought us. And there's the Jacob's ladder. He showed us some different telegraph keys, and then let's see. And then, yeah, he had a Tesla coil that he demonstrated. And you can see they have a whole bunch of little model different antennas back here. There's Anthony. They have it set up so you can speak in this microphone and you can watch the waveform on an old oscilloscope. And this was, let's see, I think this was the original plans from Morris's telegraph, where they did the first telegraph transmission. Anthony looking at more
Armstrong.
things. Yeah, that's right. That's the Armstrong exhibit. Yes. So there's the Armstrong, and this is a replica of the tower of the Armstrong Tower in Alpine, New Jersey. So they had a little model of that. I mean, the place was just fantastic. So many different things. Yeah, these are all spark gap. This is a spark gap transmitter demonstration, and they had like low power ones and then this high power 1,000-watt sync rotary spark gap transmitter, and they actually turned them on and operated them a bit. And Rachel was very happy with this because she's from Indiana, Pennsylvania, and this Atwater Kent sign, radio to the radio around the world radio. This is from a radio shop in Indiana, Pennsylvania.
Mhm.
So there's a whole Atwater Kent section. This is the Titanic radio room. And he said the reason they know that the radios were in this position, the radio room, was because when they discovered the Titanic and they sent the submarines, the remote controlled vessels down to video the Titanic, they were able to go into the radio room, and all of the gear was had all disintegrated, but the wires were still on the wall. And so they were able to recreate the radio room based on looking at photographs from the underwater wreck of where the wires were, which was kind of neat. Yeah. And then here he's showing some phonographs. So there's an Edison phonograph. And here's their Western Union station, which is really neat. So I'm sure this group probably knows this, but there's a bunch of people who like to keep doing landline American Morse code using traditional telegraph sounders. And these people have actually designed telegraph over internet protocol interfaces. So you can connect your 1800s era landline telegraph equipment to the internet and then, and then communicate using actual sounders. So the guy who usually operates the telegraph station wasn't there the day we were there, but they said often you can go in and they actually have someone who will operate the telegraph for you.
We have a member of our local club, the Aero Radio Club, Al W, K8WXQ, who does Continental Morse, and he has the setup for that. And he goes to the local libraries here and gives demonstrations.
That's really cool. I just think that's neat. I also got a kick out of this because I grew up in Bloomfield, New Jersey, and that's still where my mom and sister live, and we were in Bloomfield, New York. So I thought that was fun. Let's see. These are pictures from their modern ham radio stations. So they had an Elecraft K3 set up. That's where they demonstrate FT8 and some of the more modern modes. They did not have anything with a waterfall display on it. So that was...
but there's a P3 next to the K3 there.
Yeah.
That is a waterfall.
It'll do it.
Oh, yeah. Like right there.
Right there. Yeah.
Okay, yeah. Okay. Yeah, sorry, I missed that.
And that extra display up there might have been the external display for the P3.
Possible.
They just
Possibly, yeah.
Yeah.
It does a nice job. I've got one.
So they were I think this section of the building, the ham radio station, it sounded like it was a new section, and like they had just finished relatively new. So they've got a really nice, spacious amateur radio station there, just with, and you can see there's the tower right out front. And as I said, they just put the tri-bander up last Tuesday. Here's some of their collection of broadcast radio receivers. And this is a lot of this is about the design. So I'm always a big fan of these Art Deco style receivers, which are just, I think,
Yeah.
absolutely gorgeous. And this is one, I think, from France that was just really fantastic. That was neat. And then here's the VOA console. And these two things up here. Did I get, there's Anthony at the VOA console. Let me see, did I have, yeah, okay, these two things up here. Does anyone have any idea what these are?
No.
I had no clue. They are actual pieces of the Arecibo telescope dish.
Oh, really?
Oh,
Yeah, so this one has been cleaned and this one has not been cleaned.
uh-huh.
And it was very interesting learning about how they got some of these things. So like they, after Arecibo collapsed, they were hoping to get a piece of it and they contacted them. They're like, no, everything's been sold for scrap. And they got some tip that a few pieces were sent to some facility in the continental United States for cleaning. And so they contacted them and they were able to get a couple panels. So that's why those are up there.
Wow.
And similarly, they were saying that with this VOA console, I said, well, where did that come from? And they said it came from a relay station out in California that was decommissioned, I guess, in 2005 or something like that. And within, they tried to get it, and the people said, no, it's just going to scrap, and they weren't going to give it to them. And there was some haggling, and finally they got them to say, okay, you can have it, but you have to get it out of here within 3 weeks or it goes in the garbage. And then they said, and then on top of that, you have to have it set up in your museum 18 months from now. And so there was like a panic, and they sent a team of people over to California who, disassembled this thing within 3 weeks and figured out how to ship it across the country to New York State and then put it back together. And he said it was rather difficult. He also said this is what happens when your 8-inch rigid transmission line has a bad connection at 250,000 watts. So they had a nice demonstration of that. There's the Arecibo exhibit. They had we were looking at vacuum tubes. They had nice Radio Club of America exhibit. There's Anthony standing next to this very fancy broadcast radio that has a porcelain cat with it. This is
Full of energy.
That's the one of the radio teletype waterfalls systems. So it has like 1, 2, 3, 4 4 different radio teletypes that can receive simultaneously. So Anthony was dancing to the clattering of the RIDI system. Now this was cool. Well, this thing in the box is really, really neat because this is one of the world's first transistor radios. It was a prototype at Bell Laboratory. And it says, in the period just after the invention of the transistor at Bell Laboratories, several radio receivers of varying design and complexity were built to demonstrate the feasibility of using transistors in place of vacuum tubes and radio sets. This is believed to be the last surviving example of those sets, and it is in the design which most closely demonstrates that eventually put into production by various manufacturers. This set is a super heterodyne type and uses 5 junction type transistors in the RF and IF stages and 4-point contact transistors as an oscillator, detector, and audio amplifiers. No attempt was made at miniaturization. All other components, including the cabinet, were typical of those used in tube type portables of the time. It used 4 batteries weighing approximately 8 pounds with an expected 200-hour operating life and a speaker output of just 0.1 watts.
Do you know what year was that radio made?
Had to be like, it doesn't say, but it was probably like late 1950s, I guess.
Well,
right?
When was the transistor invented? It was first invented like in 47, wasn't it?
46, 47, somewhere in
Yeah.
there.
So maybe it was.
Yeah, but the
Oh, here,
first
there you go. I have
discussion-
it. I have an answer from you. First transistor radio from Bell Labs, 1951. There you
Year
go.
I was born.
That's awesome. And they told me a really interesting story too. They said that, you know, all of these prototypes after they were made, they were actually just discarded. And so there was a young engineer at the time who decided to go dumpster diving at Bell Labs and found this thing and didn't understand what it was at all. But he took it and stuck it in his attic. And it stayed in his attic for something like 40 years or something like that, 40 or 50 years. And then, you know, he was going through his attic and he's like, he showed it to some other people from Bell Labs. It's like, what is this thing? And someone recognized it and they said, I know what this is. That's the first transistor radio. And so they donated that to the museum. So that was a really neat piece of history. And then more RCA stuff. Anthony was interested in Nipper the dog from RCA. These are all radios made in Rochester. Yeah, and then we just got a family photo, and that was it. But
and where exactly is this located?
it's in Bloomfield, New York, which is up in the Finger Lakes. So if you go to maps.google.com, the Antique Wireless Museum.
Okay.
Okay. So yeah, so up there.
Probably
So,
up there by that commune my old girlfriend grew up on.
so it's about 3.5 hours away from me. And it was great because there's both radios and then there's also nice wineries around there. So you can go see old radios, and then go out to a winery, which is exactly what we did.
Oh, very cool.
Yeah.
I've got one quick thing to show the group here. Nathaniel, you might have already seen this. I sent something about this to you and Mary Lou. There was an interesting photo taken from the International Space Station just a couple of days ago.
Oh, yeah.
This is what
Oh,
a
wow.
thunderstorm looks like from the ISS when it produces a sprite. Now, you can imagine the amount of energy that is in this discharge here.
Wow.
And
That picture was featured on spaceweather.com today.
yeah. So anyway, this kind of thing is the reason why I keep being convinced that there must be some way we could spot the footprints of these thunderstorms in our data somewhere. It's got to be showing up in the ionosphere somewhere.
That is really impressive.
These are the ones that actually create gamma ray cascades, don't they?
Looks like something straight out of Star Trek.
Makes you
Yeah,
wonder.
but look at how lit up the whole area is from this discharge.
Yeah.
That is so amazing.
Yeah.
No, but I thought you'd like to see that.
Oh.
Well, thank you very much.
I put a link to the article about it in the chat in case anybody wants to read the article about it. But you said it was already featured in Space Weather as well?
Yeah.
Okay.
That's great.
Had a good write-up on it.
All right, I'm gonna say 73 now. Thank you, Ray. Thanks, everyone. Thanks, Bill. Thanks, everybody. Talk to you soon.
73.
Right.